Let's talk about the color change. Okay, let's talk about the color change. Flip that page over. So we said that most of the time the moon looks whitish, right? I'm just going to say white, even though it's like a whitish gray color. It turns out this also has to do with the rising and setting of the moon, right? The rising and setting of the moon. Imagine, here we go, let's draw that picture again. Here's the Earth. Here's the moon. When the moon is right over your head, most of the time, it looks a whitish color, right? It looks like that plain moon color, okay? But when the moon is rising, right when it rises, it's gonna look red, okay? It's gonna look red. Now, here in Gainesville, here where we're living, at least for some of you that might not be the case, but where I'm living, I don't typically see that red moon every time it rises. And the reason for that is that most of the time there are trees in the way, right? Most of the time there are trees in the way. But if I lived in a place like Australia or someplace like in the outback where there's less trees, at least I think that's how the outback is. Don't at me. If you go to some place that doesn't have as many trees as where I'm living, you'd be able to see the moon looking red every single day that it rose, okay? And as it goes up in the sky, it very quickly turns from red to orange to yellow back to that white color for most of its journey across the sky. And then it actually turns red again when it's setting, okay? So this is not your brain being bad at color like the moon illusion, okay? This is an effect of our atmosphere. And to help us understand that, let me ask a different question. Is the moon making its own light? No, right? So here's the question. Where does moonlight come from? Where's that light come from if the moon is not making its own light? Where does moonlight come from? Yeah, it comes from the sun. It comes from the sun, right? So if the moonlight comes from the sun, then that means it's going to have the same color as the sun. And we typically think of the sun being yellow, right? The sun's yellow, but its color is actually pretty close to white. Don't look at it. Don't look at it to check. That's a bad idea. You go blind in just a couple seconds of looking at the sun, but it's the light that the sun gives off is very close to white light, okay? So that means that the moon is supposed to be sending us white light all the time. So it's our atmosphere that affects it and makes it look reddish sometimes. So how does that work? So here's the thing. And let me just draw it down here. Here's the thing. The light from the moon, let's imagine this arrow represents a beam of light. Okay, let me zoom in on this. Let's represent, this arrow represents a beam of light, okay? And let's say that this beam of light enters a big cloud of gas. When that light enters, does anybody know what happens to light? Let me focus that. Does anybody know what happens to light when it enters a gas like this? This might be something you learned in school, but it might have been a long time ago. What's going to happen to the path of that light when it enters that gas? So as it comes through, it's gonna turn, okay? It's going to turn a little bit. Let me bring myself over here. When light enters a gas, it's going to turn. It's going to bend, okay? So imagine it coming in like this. So anytime light enters a new substance, its path will bend. And there's a technical term for that, which we're going to see a lot later, and it's called refraction. So real quick, how many of you guys have heard of refraction before? Have you learned about this at some point? It's just a fancy term for light bending when it enters a new substance. So if it entered some water, it's going to bend. If it enters some air, it's going to bend. If it enters a cloud, it's going to bend. Okay? Now don't worry if you don't remember much about it. We're going to get into a lot more detail on that later. But for now, it turns out that different colors bend different amounts, okay? And I forgot to get a bunch of different colored markers for this. But it turns out that light that is red bends only a little bit. It only bends a little bit. And light that is blue bends a lot. So let's imagine this is blue, that's red. And every other color is going to bend something in between, right? So this right here might be green or yellow, okay? So light will bend a different amount depending on which color it is, okay? So here's my next question. Based on the amount of bend here, red versus blue, which one's going to make it farther through the gas, okay? Which color will make it farther through the gas, red or blue? Based on this picture here. Red's going to make it further through, right? Red's going to have an easier time passing through gas than any other color. Blue's pretty bad at it. Purple's actually even worse, okay? But here's the important part. We said that the moon is giving us white light, okay? So check this out. How do you make white light? What color is white? White's not a single color, right? What colors do you have to mix together to make white light? Like a perfect white light. Yeah, every color. Every color. We got to mix together every color. And that means if you have white light coming in, then it's not going to just bend in one direction. When you send white light through a gas, it's like sending all of these in all at once. And so part of it, the red part bends a little bit, and the blue part bends a lot. And what ends up happening is that the colors get spread out. They don't stay together in that white color. And so if you were standing over here, if that's you, that's a person over there. If that person looks at a white light back here, if there was a white light back here, is this person going to see a perfect white light? No. What's going to happen to the color they see? It's going to get more what color for this person over here? If the light source over here was white, what's going to happen to what this person over here who's looking through the gas sees? It's going to look more... It's going to look more red. It's going to look more red because notice this blue light misses this person, right? So if you look through a gas at a light, it's always going to look more red than it really is. And here's the important part for the moon. It turns out that the more gas there is, the more of the other colors are lost. Okay? The more gas you're looking through, the more of the other colors other than red are lost, and so the redder the picture looks. So, let's go back to this picture. Right here. Okay? Here we go. What I want to add on here is the atmosphere of the Earth. Let's say that's our atmosphere, okay? That's the atmosphere of the Earth right there. Okay, imagine that the moon is right above your head, and its light is coming down. In order for you to see it, it's got to hit your head. Okay, now check it out. That light only had to go through a tiny bit of atmosphere to get to your head, okay? Only a little bit of atmosphere to get to your head. So as soon as that light hits the air, it's going to start to refract, and it's going to start losing color. But because it only has to go through a little bit of air to get to your head, it doesn't lose much of its color at all, and so you're going to see a white color, okay? But when the moon is over here, when it's to the horizon, when it's rising for this person, when it's coming up, check out the path of the light. Right? It goes from here to your head. What's different about the amount of air that light has to go through? When the moon is over here, what's different about the amount of air that the light has to go through compared to when the light's coming down from here? Is this more, less, or the same amount of air? Don't overthink it. It's okay. Nobody wants to give it a try. It's all right. So, oh, somebody did. There you go. It's more. It's more. It was probably just a delay. Good job, guys. This is more air. And that means that that light is going to lose more of its colors, and which color is going to be left behind? If it's going to lose more of its colors, which color is going to make it to your head? If you've been following along through all of this, it's going to be red, right? So when the moon is rising or setting, if it was over here, because the light has to go through more air just because of the angle it's coming in, when the moon is rising and setting, every single time, it's going to look redder than its true color. And then as it rises, it loses less and less and less of its colors, and by the time it's above your head, it looks the regular old whitish color, okay? Now, here's the thing. The moon is not the only thing that does this. The moon is not the only thing that looks red when it's rising and a more whitish color when it's over your head. What is the other thing that does this? What else looks reddish when it's rising? The sun. Yes, the sun also does this. And the sun, that's why the sun looks red when it's rising. If you've ever seen a sunset or a sunrise, the sun looks more reddish colored when it's rising or setting. And that's because when the sun is over here, most of the sunlight is lost except for the red color. The red color is able to make it through all of that air on the way to your head. And when it's above your head, it doesn't lose as much of its color, okay? There's one thing I want to point out here, though. If this was the sun and that sunlight was coming straight down, when that sunlight hits the air, it does start to refract, okay? And so what color does it start to lose as soon as it hits the air? It starts to lose its blue light. The beam of sunlight, it starts to lose that blue light. It bends out of the way of your head. But here's the question. Does that blue light disappear when it's bent out? No. Where does the sun's missing blue light go when that refraction happens? When the sun's light enters the atmosphere and it starts to lose the blue color, where does that blue color go? The sky. Exactly. Right? So when the sun is above your head, the reason that the sky looks blue is because the sun has lost a lot of that blue light and it's sent all over the sky. So the blue of the sky is actually sunlight that's just been refracted. And it's a lot more complicated than that, how it bounces around. But essentially that is sunlight that you're getting. And that's also why As the sun starts to set and the sun starts to lose more of its colors, right? What happens to the color of the sky? What happens to the color of the sky as the sun sets? Now, it does get darker because some of the light is lost to other parts of the planet, but the color changes too, right? If you've ever seen the sun setting, you probably have noticed that the color of the sky has gone sort of yellow or orange. And that's because those colors have been lost from the main beam of sunlight into the sky when the sun is setting. So it sort of all comes together, okay? So, boom. So the moon illusion is the moon changing size because your brain isn't so great, but the color is changing because of refraction, okay?